symmetric to the x-axis, what changes? The y. So the point 5, negative 3 would become the point 5, positive 3, because you told me it's symmetric to the x, the y changed. Or if you graph it, 5, negative 3 is here, so if I flip it over the x, it goes up there. Alright, if 5, negative 3 is symmetric to the y-axis, what changes? So the point becomes?
Negative 5, positive 3,
If I reflect this across the y-axis, it goes over here. So negative 5, negative 3. See, John Paul, this one has you written all over it. Okay, so if it's symmetric to the origin, what do we have to do? Change both. So what do we get?
Negative 5, positive 3.
Yes. Because you have to flip over the y and the x. So it ends up there. Alright, so
I
on...
think I knew what I was doing. Actually, all of them I knew what I was doing.
You just couldn't
First one I
say
had
it.
my x and y mixed up, and then I just accidentally said positive 3.
So this one, if I flip it across the x-axis, what does it become?
Negative 6, negative 1.
If I flip it over the y-axis
Positive 6, negative 1.
and across the origin. Alright. Questions on those? Okay, I have another slide with just some review problems. Well, things we talked about yesterday. Ignore the numbering. I pulled it off the worksheet, but I just wanted to look at these problems. So suppose that for a function, f of 3 equals 6. What does that mean? Yep. When x is 3, y is 6. So that is a point on my graph. So, kind of the same thing we were doing with the other one. Tell me what would be the point if it were symmetric to the origin.
Negative 3, negative 6.
Or if you wrote it in function notation, you would say f of negative 3 equals negative 6. Alright, if it were symmetric to the y-axis. If I flip this over the y, we would have a positive 3, or a negative 3 and a positive 6. You change the x value. If it's symmetric to the line x equals 6, x equals 6 is right here. If I am symmetric to that line, that means that if I flip my graph over that line, it overlaps itself, okay? So if I took this point and folded it across that red line, where is it going to end up? Well, 6, 6 is right here on the line. 9. I can think right now I'm 3 away from that line. So if I flip it, I'll go 3 the other direction. But it would go over here. So it becomes positive 9, positive 6. Alright, if I said for all x, f of negative x equals f of x, what does that mean? This was the definition of an even function, which means it's symmetric to the y-axis. And haven't we already done symmetric to the y? Saying a positive and negative x give you the same thing. So just change my x. For all x, f of negative x equals negative f of x. That's the definition of odd, which means it is symmetric to the origin. And didn't we already do that? Symmetric to the origin, change both the x and the y. F is an odd function. That's another way of saying it's symmetric to the origin, or that this is true. So again, we get the same thing. So just wanted to kind of practice a little bit about what those symmetries mean. Any questions there? Okay. Then make sure you have your notes out. We're going to start the next section now. So we talked about our basic graphs, and the next few things that we're going to go over are transformations. So today we're just going to talk about moving up and down, left and right. And then next week we'll get into the rest of it. All right. So, if I want to make a graph move up or down, what do we have to do to its equation? If I said my function was x squared, and I wanted to move the entire graph up 2, what do we do to the equation? X squared plus 2. We add 2 on the end. If I wanted to move it down, what would we do? Minus 2. Okay. So the vertical shifts. If you have y equals a function and you add something on the end, that moves it up that amount. If we have a function and we subtract on the end, that moves it down. So changes to y are outside the function. It's not inside the square or inside the absolute value or whatever we might be looking at. It's just tacked onto the end, and it does what we think. Adding moves up, subtracting moves down. When we graph these, I will ask you to do both a parent function and the final graph. I expect a minimum of 3 exact points on each. So we'll start with the parent function, which is going to be one of those basic functions we did in the last section. I will have you draw the parent function dashed, and then the final function solid, so I can tell the difference between the two. So let's say I asked you to graph f of x equals x cubed and g of x equals x cubed plus 4. So our first function, x cubed, what does that look like? Yeah, it's kind of like the chair function, it starts out and then it kind of levels out in the middle. So if I want some exact points, we can either make a t-chart, we can write them out. 0 cubed is 1 cubed, -1 cubed. If you know what your graph looks like, this might be enough. If you don't, you might need more. So 2 to the third is 8. -2 to the third. Alright, this is my parent function, so we're going to draw that as a dashed line. Now I want x cubed plus 4. So adding 4 on the end will do what to my graph? So what we're going to do is take each of these points that we plotted and move them up 4. And that would be our solid one, the final graph. And I could ask you questions about that if I said, what's the domain? What's the range? So domain and range, those are common questions for any graph that we draw. Is that one okay? Let's look at another. So I want to graph f of x equals the absolute value of x, and g of x equals the absolute value of x minus 2. Alright. What does the absolute value look like? Absolute value is 0, 0, 1, 1, 2, 2, negative 1, 1, negative 2, 2. So you have to have at least 3 exact points. That's my parent, so it is dash. I'm looking at my final one, but what does the minus 2 do? So we take these points that we just plotted and move each of them down 2. What's the domain of that? Negative infinity, positive infinity. What's the range? Negative 2 to positive infinity. All right. Any questions on those two examples? Let's talk about a horizontal translation. So horizontal, if we know it's affecting x because it will be inside the function. It is attached to the x itself. So outside is y and it does what it says. Inside is x and it does the opposite. So adding a number actually moves it in the negative direction. So it would end up going left. Subtracting a number moves it in the positive direction. So it would go right. So y is the outside, does what it says. X is the inside, it's the opposite of what it says. So what's our parent function? X squared our parabola. 0 squared is 0. 1 squared is 1. 2 squared is 4. Negative 1 squared is negative 1. Negative 2 squared is, negative 1 squared is 1. Negative 2 squared is 4. So if I said g of x minus 3, that means the equation is like x minus 3 squared. So the 3 is on the inside, so it's changing x, and it does the opposite of what it says. So this would move my graph right. 3. Take each of our points right. I ask for g of x plus 2. So that's like saying x plus 2 squared. What does the 2 do?
Moves it left.
Inside is x, does the opposite of what it says. So adding moves it to the left. So we're moving the original left. Is that okay? Let's try. I'm going to put a few up here. We're going to have to figure out what the transformation is on each. So A. What am I going to end up doing? 1. I know it's not inside because it's not being squared, so it's changing y and it does what it says. Parent function would be what? X squared. So 0 squared is 0, 1 squared is 1, 2 squared is 4, negative 1, 1, negative 2, 4. And then we just take each of those points and move them up 1. B. What is this one doing? It's inside the square, so it changes x. Does the opposite of what we say. So subtracting will move it in the positive direction. So we're going to take it right one. The same parent function. Move each of them to the right. Is that okay? Do we need more like that? We can also have more than one transformation in a problem. So we're going to do a few with multiple transformations. We'll also practice giving the domain and range at the end, just to make sure we've got that. So on A, what is my parent function? X squared. 0, 0, 1, 1, 2, 4, negative 1, 1, negative 2, 4. You guys all know where I'm getting those points, right? Okay, what is happening to this graph? The -1 would move it, and the +2. So we can move each point right 1, left 2. What's the domain of that? What is the range?
2
I want you guys to try B and C for me.
You want us to do the graph also?
Yes, draw the graph. The first one, the x cubed. You have your parent function. What transformation do we end up doing on this one?
Doing the left one down to
So left and down. And you get something like this. Domain
main infinity constant thing.
and range. C, square root function. What does it look like?
It's kind of like a
Square root of 0 is 0. Square root of 1 is 1. You can do the square root of 4 is 2. You can't put in negatives, so it looks like this. And our transformation, this time it would go
Right, 2 down 3.
right 2 down 3. Follow those. And we'll get this graph. What's the domain of that?
2 to infinity.
Mm-hmm. Range?
-3 to infinity.
Alright. Any questions there?
We just domain the new one.
Yes. Yes, just the final one. Do we need more practice with any of these? Then my last slide. I'm going to give you a graph, and I want to know, can you tell me what the equation is? So all 4 of these, what's my parent function?
X,
What did this do to the normal absolute value graph?
shifted it down to
Okay, so what equation would make it go down to?
absolute value of x minus 2.
I'm going to do C next. What did this do to my equation?
Moved it over 4.
So what would make that do? What would make our graph move to the right 4?
Absolute value of x minus 4.
Alright, you guys do B and D real quick. So this one went up. So you'd have to have the absolute value of x with a plus 1 on the end. This one went left, so left and right means it's inside, but inside does the opposite. So to move it in the negative direction, we would add 2. Alright, so that's all I have for today. There is a Math Excel assignment open.